Okay, this is Mr. Sitta. I'm going to go through the Chapter 11 review on balancing equations now. I waited to post and go over this review, and this is one of the things we had taken before we left. You have a multiple choice test, a multiple choice review that you took on balancing equations. And I'm going to give you a similar online test, and it's going to be multiple choice on Tuesday. So I want you to have this to go over the weekend and be ready for the test on Tuesday. I'll apply it 11 to 12 o'clock, if that works with everybody. All right, here we go. Number one, after the correct formula for an equation that has been written, you cannot change the formula. So that is to say the subscripts. Subscripts don't change once you have a correct formula written. You keep them. You're only changing the coefficients. In writing an equation, how do you write hydrogen gas? You always have to remember Hankelbrief. These are the magnificent seven on the periodic table. These are the 7 molecules that are always diatomic when they have no charge. So if I write hydrogen, I write it H2 the same way I would call oxygen O2. What is a small whole number that appears in the front? Well, that's called the coefficient, D. Okay, according to the law of conservation of mass, the total mass of the reacting substance is always equal to the total mass of the products. A chemical equation is balanced, okay, when you have B, the same number of each kind of atom in the reactants as you do in the products. So when it comes to balancing equations, the products, the reactants are on the left, products are on the right, and your number of atoms of products has to equal your number of atoms of reactants, and that's why you're balancing it. That is an R, reactants. Okay, what does the symbol delta mean? Okay, when you see delta, that means heat is applied to the reaction, and delta can also equal change or heat. Okay. A chemical reaction, okay, produces new substances. Okay, the atoms rearrange themselves, and you have brand new substances with brand new properties. Which of the following is not true statement about what happens in all chemical reactions? You don't get new atoms formed. That's what the Greeks thought. They thought that one element could transition to another element. That's the idea of meta thesis. Okay, to transpose. Chemical equations, they describe chemical reactions. In a balanced chemical equation, number 11, each side of the equation has the same number of atoms. Okay, and to get the atoms, it's always the coefficient. So if I had like C6H12O6 and I had a 3 in front of it, the number of hydrogens would equal the coefficient 3 times the subscript 12 would be 36 atoms. Which coefficients correctly balance the formula equation? Okay, to balance this, I would look at nitrogen. I have 2 as a subscript, but you have 1 here and 1 here, so that's 2. Then I'll look at hydrogen. You have 4, so I need to put a 2 in front of that. So I'm ending up with a ratio of 1 to 1 to 2, which is B. Which equation is not balanced? In this last equation, you have 2 times 2, 4 hydrogens. You only have 2 in water, so the answer is D. Okay, keep going. All right, now, I'm looking at balancing this equation. This is be a double replacement. You have one ionic compound plus a second ionic compound, and the cations and the anions are basically switching. That's a metathesis. Look at my ratios. Aluminum sulfate's 2 to 3. KOH is in a 1 to 1 ratio. Aluminum hydroxide's 1 to 3. These are my subscripts, 1 to 3. And then 2 to 1, that's one sulfate, so this would be 2 to 1. Okay. Now, I would start balancing with the most complex ratio, the 2 to 3. So I need 2 aluminums, so I'm going to change the coefficient on this side with a 2. I have 3 sulfates, so I'm going to put a 3 in front of this side. And that would be 3 sulfates, not 12. A sulfate is SO4. Now, I'm going to look at my hydroxides, and I'm going to look at my potassiums. The number of potassiums on this side is 3 times 2 is 6. So to get 6, I'm going to put a 6 right here. And the hydroxide was 2 times 3, which makes it also have 6 hydroxides. So my ratio I'm looking at is, at the end, 1 to 6 to 2 to 3. Those are my coefficients. And that lines up with E. What are the missing coefficients? Again, this is a double replacement or a metathesis reaction. I would start off looking at the hydroxide or the chloride, because they both have a subscript of 3. Doesn't matter which one. This is a 1 to 3 ratio, and this is a 1 to 3 ratio. So either way, I would start with the chlorides 3, and I would put a 3 in front of this side. If I started with the hydroxides, I would put a 3 in front of that. Now either way you're going, you just put 3 sodiums in it, and there's your 3 sodiums, and over here you just put, you have 3 hydroxides, and that put you 3 hydroxides, 3 sodiums, so it's balanced. And the ratio is 1 to 3 to 1 to 3. And that would be C. Okay. This equation is a combustion, and a combustion always has oxygen as a reactant. So in a combustion, you normally see as a product, in the reaction, you're going to see heat and light. And if you've seen the gummy bear reaction, that's a combustion reaction. You get a lot of heat, you get a lot of light, and if you have a hydrocarbon, which you do here, you're going to always produce CO2 and water. Okay, so it's a special reaction. It's also a redox, so it's a combustion and a redox. Okay, the 4 types, it doesn't really fit well. If anything, it's kind of a decomposition, but you don't start with one thing. It's almost like the hydrocarbons being broken up. All right, the last thing I'm going to balance is the oxygen. Second last is water, so I'm going to start with carbon. I have 8 carbons here, so I'll put a coefficient of 8 in there. Now I'm not going to do the oxygen until last. I'm going to do hydrogen next. I need 18, so I'm going to put a 9 in front. 9 times 2 yields me 18. Now I'm looking at the oxygens. The oxygens here have 16, 8 times 2, plus 9 times 1 is 9. I need 25 oxygens. Now, it is okay in a combustion to use 1/2 for oxygens. So if I need 25 oxygens, they come in 2s, so I'm going to divide it by 2. So I can put 25 halves. Now that would be correct, but I don't see anything here with a half. And what they've done is you're allowed to double all your reactants. So when I double this, I end up getting 2. That makes this 25. 2 times 8 is 16. 2 times 9 is 18. So they just double everything, and your ratio ends up being 2 to 25 to 16 to 18, E. Okay. What's the coefficient for HCl? There's a single pure element, magnesium plus HCl. This is called a single replacement, and the metal magnesium is replacing the hydrogen. It's also a redox. It's anything that starts elemental on this side, it'll have a +2. Hydrogen at a +1, it'll go down to a 0. Okay. And so what's getting replaced is the hydrogen gas. And the magnesium is replacing hydrogen in solution. So this is a single replacement. All right. I would do anything by itself last. That's the hydrogen and the magnesium. Okay, I see that I have 2 chlorides here, so I'm going to push a 2 in front of the HCl for my 2 chlorides. That gives me 2 hydrogens, and now I have H2, so that's balanced and 1 to 1. So my ratio is 1 to 2 to 1 to 1. And they wanted the coefficient for the HCl, and it's just a 2. All right, I have another combustion reaction. This has oxygen in it, so this is a carbohydrate. Okay. And again, I'm going to do oxygen last. I'm going to do water second to last. So I'm going to start off with the 2 carbons. So I end up with the 2 here. I have 4 hydrogens, so I'm going to put a 2 in front of the water. Now I'm going to look at the oxygen last. 2 times 2 is 4 oxygens, plus 2 times 1 is 2, so I end up with 6 oxygens. Now I already have 1 here, so out of my 6 oxygens on the left side, 1's already accounted for. So I need 5. I'm going to divide that by 5 by the 2, so I get 5 halves. All well and good, except they don't have anything listed with a half. Well, because it's a half, I can just multiply every factor by 2. Just double everything. So I get 2. 5 halves times 2 is 5. And then double it to 4, and then double it to 4. So the balance equation is 2 to 5 to 4 to 4. They only want the coefficient for oxygen, and it ends up being 5. When the following equation is balanced, the coefficient of water is what? Okay, this reaction is 2 things plus 1. 2 things together make 1 thing. So this is a synthesis problem. It's not a redox equation. Nothing's changing charge. But it is a characteristic. We see nonmetal oxide plus water yields an acid. So that's a characteristic equation. Non-metal oxide plus water always makes acids. Metal oxide plus water would have made a base. Okay, well, let's just balance it. Okay, I'm going to balance water last. So I'll start off with the nitrogen. I got 2. So that gives me 2 nitric acids. There's your 2 nitrogens. Now this is why I'm doing water last. Next I'm going to look at the oxygens. I have 5 here. Here I have 2 times 3 is 6. So I end up with 5 plus 1 equals 6. And then there's your 2 hydrogens and 2 hydrogens. So that's balanced when you got the ratio is 1 to 1 to 2. Okay, and the coefficient of water would be E1. Okay. Which of the following is a combustion reaction? I'm looking for a combustion plus oxygen on the left. And that's what a combustion reaction is. When you have O2 on the left side of a reaction. Number 1 is a combustion. 2 is not a combustion, no oxygen. 3 is not a combustion, and there's oxygen on the left, so 1 and 4 are both combustion reactions. And what kind of reaction are 2 or more substances combined to form a new compound? The key word is when it says forming a new compound, and that would be synthesis. So in a synthesis, 2 things make 1 thing. Okay. What's a general equation when you have AX plus BX? Well, this would be cation, anion, and anion, 2 salts, and then they're switching partners. And that would be what we see as a double replacement reaction, or what we call a metathesis, producing a solid, liquid, or gas. And what kind of reaction does a single give 2 or more reactions? So if I have a single thing, XY, and it breaks down to X plus Y, that is the sign of a decomposition reaction. If I have one thing plus two things, so a pure substance plus a salt, the A replaces the B, and that's a sign of a single replacement. That would always be a redox because the A would have zero charge, and on this side A ends up with a charge. On the right side B had a charge, and it ends up with no charge. So single replacements are also redox as a special reaction. Here's that type of reaction. I have one pure thing, magnesium, plus HCl. The magnesium's replacing the hydrogen, kicking the hydrogen out, and that's a single replacement reaction. And I'm going to come back and create another video to finish the rest.